Today we'll be discussing congruent triangles. First, what is a congruent triangle? When we have two triangles that are congruent, they are the same size and shape. We use an abbreviation when we're doing our proofs, CPCTC, and this just means that two triangles are congruent if and only if their corresponding parts are also congruent. So this abbreviation is really nice whenever you're doing your proof, because then you don't have to write out the whole thing, which is corresponding parts of congruent triangles are congruent. That's a lot to write out when you're doing proofs, so that's why we use the abbreviation. Alright, so let's look at an example down here. We have two triangles. We have our two triangles here. And then we have some statements. We know that angle Q is congruent to angle T. So we're going to mark here Q is congruent to angle T. And then we know angle R is congruent to angle U. Angle R, two lines, is congruent to angle U. We also know that angle S is congruent to angle V. S, so I'm going to use 3 lines, is congruent to V. 3 lines. And we have some segments here. We have QR is congruent to TU. So QR over here is congruent to TU. We also know that QS is congruent to TV. QS is congruent to TV. And we know that RS is congruent to UV. RS is congruent to UV. So then we're going to name those congruent triangles. So if all of these pieces are marked, in order to name congruent triangles, we're going to start out with our triangle symbol, and then we're going to go in order. It doesn't matter whether you go clockwise or counterclockwise. I'm going to start here with Q, so the angle with 1 hash mark, to the angle with 2, and then to 3. So we have triangle QRS is congruent. So again, we're going to start same place here. We have triangle T has 1, U has 2, and V has 3. So then when we look at this statement, we can actually see which pieces are congruent. We said Q is congruent to T, and they're both in the first position. We said angle R is congruent to U, they're both in the second position. And then angle S is congruent to V, and they're both in the third position. We can also see our segments. We have QR and TU, or QR and TU. QS, the first and last, is congruent to TV, which is also first and last. And then RS, the last two, and UV, the last two. So just from this statement, I could have pulled all of this information. Alright, let's try another example. So this one's a little bit different. This is working with vertices. The vertices of triangle CDE are C is at a negative 5, 7, D is at a negative 8, 6, and E is at a negative 3, 3. And then we have the vertices of C prime, D prime, and E prime. C prime is at 5, 7, D prime is at 8, 6, and E prime is at 3, 3. So then it says, is triangle CDE congruent to triangle C prime, D prime, E prime? If so, we're going to name the transformation that was performed. So if you remember when we talked about transformations, those were our slides, our flips, our rotations, any of those kinds of things. So we're going to take a look here. So in order to decide if these are congruent, we're going to be using our distance formula. So we have the square root of x minus x squared plus y minus y squared. Okay, so the first one we're looking at, we're going to look at CD. So for CD, our x values, we have a negative 5 minus a negative 8 squared plus our y values, 7 minus 6 squared. And then I'm also going to be looking at C prime, D prime. C prime, D prime. So that is the square root. And then we have our x values, 5 minus 8 squared, plus we have our y values, which are 7 minus 6 squared. Okay, so let's look at those first. So a negative 5 minus a negative 8 minus a negative turns into a positive. So we end up with difference between our 5 and 8, which is 3, and that's going to be positive, plus 7 minus the 6, we're left with 1 squared. 3 squared is 9, plus 1 squared is 1. So we have the square root of 10. I'm going to leave it like this, and then I'm going to work on my c prime d prime. So over here, we have 5 minus 8. That gives me a negative 3, which is squared. 7 minus 6 is 1 squared. Negative 3 squared is 9, plus 1 squared is 1. So we have 10. So these are the same, so those are congruent parts. So I'm going to go ahead and go up here on my picture, and I'm going to mark those as being congruent. Alright, the next one, we're going to look at CE. So C is a negative 5 for the x minus a negative 3 squared, plus our y values, which are 7 minus 3 squared. I'm going to do the same thing for c prime e prime. Square root, c prime is a positive 5 minus e prime, which is 3 squared, plus our y values. We have 7 minus 3 squared. I'm going to slide down here just a little bit so we can see those. Alright, so then over here on my CE, we have a negative 5 minus a negative 3, so that becomes plus a positive. The difference between our 5 and 3 is 2, and that goes with our negative sign here, so that's a negative 2 squared, plus 7 minus 3, so we end up with a positive 4 squared, and then our square root symbol over the whole thing. So then we have negative 2 squared is 4, plus 4 squared is 16, square root symbol, and then we have 20. I'm going to leave it there. I'm going to come over here to my c prime e prime. 5 minus 3, we have 2 squared, plus 7 minus 3, again we have our 4 squared with the square root symbol. So we have 4 plus 16. So again we have square root of 20. So these two are congruent. So I'm going to go up here and mark them again. So I have CE prime and just CE. So those are congruent to each other. So then the last ones we have DE. So we have our square root symbol. So the x value for D is a negative 8 minus a negative 3 squared, plus 6 minus 3 squared. And then when we go to D prime, E prime, we have square root. For D prime, we have 8 minus 3 squared, plus our y values are 6 minus 3 squared. So coming over here to DE, negative 8 minus 3. So we're actually going to be adding those together there. Oh, I apologize, this should be a negative 8 minus, that should be a negative 3. So then we can add that, so we're going to be doing the difference again. So we're left with 5, and that is a negative because the 8 is larger, squared, plus 6 minus 3 is 3 squared. We're using the square root symbol over the top. Negative 5 squared is 25, plus 3 squared is 9. So we end up with 34, and there's a square root symbol there. Let's come over to d prime e prime. 8 minus 3, we're left with 5 squared, plus 6 minus 3 is 3 squared. We have the square root symbol. 5 squared is 25, plus 3 squared is 9. So we end up with square root of 34. Those are congruent to each other, so I'm going to mark those. Okay. So now that we have all three of those sides are congruent, we can say yes, those are congruent triangles. So then it says if so, so I'm going to go ahead and say yes. If so, name the transformation that was performed. Well, this wasn't a slide because we're not in the same orientation as we were here. This is actually a reflection over our y-axis. So yes, and I'm going to put reflection. Okay, that's all for today. I'll see you in class tomorrow.